There are 2 rolling joints to be assembled, where the knuckle joint consists of a pair. So 3 in total, held together with 2 different ligaments, and that way there's only 2 crimps. I have spent a fair amount of time experimenting to find a way to put it together which will be largely self-healing. So in the event of a big unexpected twist, the joint should just reassemble with a bit of massaging. Still very strong, very loose. Kind of curious to see how long this lasts. The parts are on the GitHub. You've got to print them out, peel them, try and get rid of any little sharp bits sticking up. There are some holes which want to be clear. They look a bit blocked. Yeah. And for that you will need a 1.2mm drill, ideally. Give or take. And that doesn't even need to be twisted a lot of the time. Yeah, maybe it does here. Plastic doesn't always cut as well as you might like with a drill, so sometimes it's actually better to push them through. And that will then push out these little bits of print support, which, depending on your settings, may or may not be in the holes. Anyway, the point is they want to be clear so that you can get a needle and quite a few strands, sometimes 3 of these, plus the needle and the spare one behind it. So it needs a bit of clearance. That is the 80-pound stuff. And the needle is a 0.9mm needle. Oops. Oh, that's interesting. Huh, right, so the body of the needle is about 0.75. The head is a little bigger. That makes sense. Up to 0.91. That definitely fits. Slightly bigger drill, slightly bigger needle, slightly smaller thread. Lots of variations, but you know, you've got to be able to pass the ligament down through these holes. I shall do my best now to remember what I've just done. To put this together, you're going to need one of the knuckle pieces, and you want to make sure that you've cleaned out down in here, because you're going to park a servo in there afterwards. That's one of these. And you want to make sure that it goes down nicely into that. Now if you look carefully, you'll see that the holes on top are at an angle, holes on the bottom are nearer to the servo. So these holes actually go like that, and that's done in order to miss the tab sticking outside of a servo while still keeping the length of the knuckle as short as possible. And it's a little bit oversized. For a child, so it will affect the character, how people perceive the robot. I don't think negatively. I'm fine with it looking handy, as it were. Anyway, clean out all your holes. You see it's a bit sticking up a bit. Either just by pushing it through or turning it in a drill, whatever it takes until you can see daylight through those. So there's that piece, which is the knuckle. There's the knuckle cross, which I need to print because the other ones came out something slightly wrong with them. Give me a moment. So there it is, hot off the press, hot off the printer. And as this is quite a tight fit, it's probably a good idea to just expose that enough that it can be run in the groove, which will be on this piece. That's that groove there, which prevents the yaw from twisting. And if that doesn't run freely with the other joint surfaces touching, then you can heat this up a little bit and then just press that in and run it backwards and forwards. And in some ways that's quite nice because this is serrated and it can give a nice little indentation which increases the accuracy of that. Something I'm considering doing actually is making it necessary so the joints actually get fitted by heating and pressing together. You can get a very, very good fit, of course, but it does introduce a new element of skill, so I'm not sure people are ready for that yet. In fact, it can't be one of these, it's one of these ones. Yes. Okay, so these are our pieces. I'm just going to peel that and we can start doing some stitching. Shake them off cleanly, careful not to damage your joint surfaces. If possible, pull bits off rather than snapping them. Get what's down inside the hole. Probably a bit warm, this one still. Tend to go a bit better once they've cooled down a tiny bit more than this one. That's why you normally wear gloves. It's annoying if you start bleeding because you get it all over things. Those holes have closed up a little. Possibly because I only printed one. Normally that would be printed as part of a set, so the print will come out slightly differently to how it normally does. Yeah, drill those holes. That's interesting. Cardinal rule of cutting is never cut towards yourself. Okay. So we have the knuckle joint, which is at the bottom there, so that's the knuckle joint, bottom there, top with the holes slightly in position. That will form the pitch joint with one side of the knuckle cross. And then the proximal metacarpal, and these come in different sizes. This is how the length of the finger changes. This is for a little finger, this is for the middle finger, and the ring and the forefinger. Is like that. So little ring and first finger, index finger, middle finger, long one in the middle. Okay, I've already made 1, 2 normal ones, so this one will be either a little or a middle. Probably easier to show you with that one because it's bigger. In fact, here you can see that runs rather tight in there, rather too tight. So I'm going to put a bit of heat. HOPELite softens very easily. And we're going to push that in and move it around. And that will effectively make its own joint face. I've heated up the top of that one a tiny bit too much. Okay, so that's how you fix that. So that will be the yaw joint, and this will be the pitch joint with the knuckle. You're going to need your 0.8mm needle. You're going to need 1.5 meters of this stuff. Most easily cut with either a proper pair of Kevlar scissors or a very sharp scalpel, a proper blade. And you want a nice, neat, square cut end like that, which you can slightly flatten, and then it should be fairly straightforward to stick through the needle. Now there must be other ways of doing this. The way that I'm quite liking at the moment starts with the lower yaw joint. So it does this one, and then it crosses as it happens by going down here at the back, and then does these joints with overlaps in many areas to make the whole thing stiffer and more stable, and then put the needle on the other end and finish off the top, and then you pull them through and tighten them off underneath, and that way you can apply tension to both sides of the joint as you're building it, and make everything nice and neat and square and under reasonable tension just with hand tools. At the end I am using a vise to hold one end of a tendon, one end of a ligament, while I pull against it. And if you don't have a vise, you'll have to somehow screw the other end of the ligament to a desk or something. It's a ligament because it's joining bones. Tendons are what transmit power from motors or muscles down to the structure. So, starting with the lower yaw joint, but each has got 2 cruciates, so we're going in the top one. And you want to pull that through about 1 meter, so you've got about ½ meter left. And then just come back round and do a complete loop. And this is handy because it will keep things more or less in the right position. So this other bit here, you want about ½ meter to the end, and about 1 meter on the other side. And sure I can get far enough away to show you that, but you know, one side is longer. The side of the needle is 1 metre, the other side should be 1/2 metre. So the way that this works is that pairs of cruciate ligaments hold the joint together, and they are arranged normally how this bottom one is done. This is what I prefer. This is what I prefer, where there's a pair that goes inside and a pair that goes outside. On top, they're staggered. Now, as it happens, it doesn't really seem to make that much difference to how they go back after an incident. So maybe it really doesn't matter, but I tend to do it in pairs. Maybe there will be different styles. So having done that first loop, the needle has now come out the bottom, which means it goes in the top. And you need to just pull enough through so you can put the two halves together without getting in each other's way. And now when you pull that, you've now made one cross. And looking at our example, I do not bother. Okay, so on this side, because there is a central ridge to prevent rotation, I'm not bothering to put these extra twists up here. In fact, more than that, I'm not sure it actually works if you try. So you just go through that hole, back up here, and back in the top of this one. Now, if you get a little knot form like that, it's better to lift it up and undo it than just pull it through. Okay, so you can see what we've done there. Just formed a pair of cruciates. You can give that a little tug. Now on this side, however, we are doing, where are we? We're here. Okay, so we'll end up with a second loop there. Right, so that one, in fact, now just pulls down till it clicks. And this is now, oh, no, wrong one. So the one on the bottom, just pull it tight, pull it across. Take your needle. In fact, you can just stick it in the top. And as you pull it through, it's going to form one side of the cruciate. And now if we look into there, you can see that this one which crosses has to go on top, like, no, it has to go in the middle. It has to in fact go through that gap there. And that will give us one pair on the inside and one pair on the outside, which I think is slightly more stable. Okay, pull that a little bit tight, just give it a quick tug. That passes back down that hole where it'll emerge from the underneath. Make sure everything's gone into the right place back on top, and that should start to work already. Pull those two tight, and now this is going to start to form the bottom of the pitch joint. Well, it's not the bottom as you look at it, is it? So in fact, where you identify is that the top of the finger has got these two details. This is the hole which will admit the Bowden tube for flexing the second joint, and this is to take a pin, which is to receive the tendons which come from the knuckle motors. So what you've done is bottom, in the sense that when the finger's lying on its side, it's the one which is away from you. And the procedure is exactly the same. Just make sure your wires are in the right place. Make sure you've still got about 50 centimetres on the end of that one. And now, if that's on the top, it's going to go in the bottom of the knuckle, which is not quite symmetrical. Holes are not the same. So it's going to go in there and come out there. And you see, if you hold those together, that's how that will look. So, in order to make this joint stiffer, don't go straight back. I'm going to pass back through there and up there. Check that the offset in the centre is as it should be. There's a little bit of adjustment possible afterwards, so you might as well get it right each step of the way. And then give that little tug. Push up against it so you've got a bit of preload in there. And then pass that back down through there. It's a good idea to blunt the needle, A, so you don't stab yourself, and B, so it doesn't accidentally get stuck into the other thread as you're going. And then just pass that one down like that. Give a little tug and repeat the process. Up there, into here, round and back up into there. Back down there. Done a full loop, and now looking into here, you see we want to be on that side, cross up into there, back down this hole. That is a second pair of cruciates formed with extra loops on the knuckle side to secure things. Okay, so there's going to be one cross thread plus the crimp on the inside. Goes up there. So that's one cruciate. One loop, one complete loop, the other side of the cruciate, no, well done there. Oh, got in the wrong hole, my bad. So, what's happened here? Why, I've missed one. Oh, it was all going so well. I have not gone back. Overdid the loop. Right, so, my bad. So you do half the cruciate and a loop, come up back where you were, pass down through the centre. That will complete the cruciate. Back up that hole. Make sure you're happy with the positions of everything. Give it a little tug, and then over to the next one and repeat. So down there. In here. Do a loop. Finish off the other cruciate, making sure that it's in pairs. little tug. Okay. There we go. Right. So that one will end up being crimped into here, and this one will now form the other side. So you just pull them against each other a little bit so that everything is nice and tight, and now we're going to swap the needle to the other side. Cross back up and do the yaw cruciates. So that's just going to be down here. In here. Okay. Nice and tight. Pull that across till it clicks. It's going to go down there. And then through the middle. Make sure everything's in the right place. And up there. And that completes the second yaw pair of cruciates. So it can be moved. Okay, pull that tight. And now this one does the opposite of this little diagonal and drops down there. Oh, yes, okay, so in fact, before I took the needle off the other one, I should have done this. Oops. Which is just to do as many loops as you can fit through, as this will reduce the amount of clamping force that the crimp actually has to provide. So this time we'll just put it back on, but you can do it. So once the end becomes damaged, it can be a bit of a pain to get through. Sometimes it's easier just to chop off the fresh one. Sometimes not. So I'm going to just end it with some loops. Okay, and then I'm using number 2 leader sleeves, which are just little tubes of metal that are 1.92 millimeters external and a wall thickness of 0.5 mil. So the hole down the middle is about 0.9. Which is just about okay. To get these down. Particularly if they're not damaged. Now, with all the triple loops, there's not a huge amount more you can do at this point, so you just pull back tight. And if you want, what I normally do as well, but might not be necessary all the triple loops, is to hold one end of the string in a vise, the other end in a pair of pliers, and then you just get a pair of plumber's wrenches, crush that flat. See if I can show you that. If you haven't got a vise, you can just get a clamp. So one end of the thread is clamped. You just have to pull against, and then grab that with a pair of pliers and just twist it around. And that'll give you something to pull against. And then just crush that crimp. So you can grab hold of it first, and then put some tension on the line, and then just crush it, and then with two hands. And that will go very flat. It can be pushed flush, with a scalpel trimming away from the rest of the lines. Just trim that off. And that will give you a nice little self-healing knuckle joint. To finish that off, to get to a full finger, you need to do this lower joint, which I'll do now, add the springs, and then the servo sits in there. And there are, well, 5 of these to assemble. The 4 fingers, I'm pretty sure, are not going to change. The thumb I haven't built yet, and I don't think I will get around to building it this week because it's already very late. So I will put out the finger and the instructions. You can build the thumb if you like. I can't guarantee it won't change. And there's also this piece, which is what they slide into. So that's quite nice actually. Once the finger's assembled, that servo sits in there, and then this whole thing once you line it up, it slides back into there, and that's how fingers go into the hand. Can't I quite like that. I'll also publish this, but I suspect there are going to be some mods, and again I might not get around to that, largely just to do with the clearance of this Bowden. I think it's possible to do something clever down in these gaps, but again that's going to probably take a second draft. So for first draft I think the Bowdens might just be a bit long, so we can get away with. We shall see how far we get. Right, but just the other thing to do would be put one of these joints together. Okay, the second joint, because these fingers only have 2 joints, 2 pitch joints, as we go as well at the knuckle, is comprised of these 2 pieces, which is the distal metal carpal, distal end of the proximal metacarpal, it's a bit of a mouthful, and then the DMC, distal metacarpal, which is kind of amalgamation of the last 2 joints of the finger. They are held together by a simpler joint, just a single pitch, which looks like that. And the trick to this is that you want to get the crimp on top so that the inner surface doesn't have a metal ferrule on it. Here's of course one down there, which, yeah, well, there we go, such a life. Okay, so to do that you need not as much, about 60-70 centimeters is enough. Same stuff, the 80 pound, 0.45 millimeter. Start with something very sharp to get to a good edge. Try and do a better job than me at keeping track of your needles. the pattern on this one is simply to start at the top and work your way down. The question is how to ensure that this ends up on that side. As you can see, it means that the end, that loose end, should be up here, so it means you just go in the top. In terms of how it clips together, there's a recess which fits onto there, and that tends to be away from you. So as you look at it flat, they're like this. That dovetail is on that side, and that's the joint. So straight down there, leave some, I guess about 20 centimeters or so in the top of there. Okay, just make sure everything is in the right hole. And now you can see how the cruciate's going to form. Just cross back over that way. And back in the top. Okay, so that's the first cruciate. About 20 centimeters left up there is probably more than enough. That's 20. And this whole piece is 70. And now underneath, oh, see, it's got the wrong one. That now crosses over to the inside. Goes up through the middle, down there, back up through the middle, and you see it does go through the middle to keep the pairs. So an inner pair and an outer pair, and then back down that hole. Looking at that, yes, that's fine. Okay. Give me a little tug. That crosses over to here, and then you just repeat it. Again, checking they are inner and outers. Just keep everything in alignment. Okay. And that is all it takes to do those, to do that front joint. So probably better to start with that one. Give you a bit of practice. And now, similar principle, just want to make sure that the crimp is not taking too much weight. This stuff is incredibly slippery, so unless you do some extra loops, the crimp just won't hold it. Well, I couldn't get it no matter how much pressure I put. And you can see we just wrap some extra loops. Again, just as many as we can get away with, really. Let's count that. So that one just had the 2. Okay. So transfer the needle to the other end. That wasn't a good one. That's not going to work. And when it does work, it's super easy. Just give it a good tug. Push it down there. Okay. Same thing. Pull those off. Take a crimp. Pass them in opposite ends so that they cross inside. Okay. Again, we can use a clamp. Move the other end, just grab hold of this. And just like cutting towards yourself, don't pull something hard towards yourself which can easily slip. It's a very easy way to damage yourself. Okay, so just going to grab hold of that crimp. And crush it. And that should lie flat. And that is a nice break resistant rolling joint. It will loosen up over time, but already that's about what you want. Very strong, very low friction, very cheap. To finish off the way the finger attaches to the hand, this is the very first one. It's a bit rough, but otherwise the design is the same. And you can see that there are springs held with screws. Now I have spare screws from other servos. Apologies if you do not. You have to find some little screws. There's a pin here, 12mm, 2mm pin. That secures the long flexor. The long flexor comes through this Bowden cable, which is a single, well, which is a long length of spring, same as the springs which are used here in fact. These are 3mm outer diameter, 0.4mm wire thickness. That one is 20mm long, that one is 25mm long. The holes are provided. This is the same stuff, 3mm outer diameter, 0.4mm wire thickness, and you get 1 meter length of it. I'll put some links. It's a slightly bigger one, but it's the same stuff. You just get a length of it. And inside of that is PTFE, which is the standard stuff used on the Dex hand and in printers, and that's 2mm outer diameter, 1mm inner diameter, and it fits down like a treat. And that's what's used to transmit the power from the forearm servos, which are back here. So if you want to try and wire one of these up, and you've had experience with a Dex hand, it's very straightforward. I don't think I'll do a video right now tonight. I'm getting too tired, but you can at least assemble fingers, and that's what it looks like. So you can play around with that. And there's now some video to follow showing this finger moving. That's all, folks. Okay, some misalignment here. Huh. So that's movement. Not very strong. I've had a brown out. Oh, some force. Okay, that's the first draft. I'll tidy it up. publish it tomorrow. In terms of construction, you can see there are loops of ligaments passing through the sections. In order for it to finish, this one I didn't do quite right, this one I think is okay, and you need the strings to end up together underneath. There's a pin here which holds the long flexor, there's 2 springs, there's a pin through the middle there, and then PTFE is quite long to protect the tendons as they run over the knuckle. Not really aiming for precision, aiming for robustness and very low cost. And the joints are largely self-healing. Pull things back into alignment and it all goes back, and that I do like. So you should be able to give it a fair amount of damage and it'll keep on ticking. Oh, this is the new bowline cable. PTFE lined stainless steel spring. Okay, so empty, it's 10 grams. And they're 10 grams. That's 70 grams. Ah, can lift 70 grams. What else have we got? $103. Doesn't like that, does it? Not sure it's starting from a very good position there. Can hold it, but it can't lift it. Grams. Yeah, it will lift 80 grams. And now we try with a stronger attempted lift position. Oh yeah, easy peasy. I don't think that's too bad. All right, let's see how much more we can lift. I think I'll make the down position not as stretched back, give it an intermediate position. Okay, so now it's only going to go down to that amount. We can see how much it can lift. So let's go back up to what we had before. Last time that weighed 100. Yeah. Okay, 105. So starting from this position, can it lift that? No problems. What's next? 141. No. Pulling 2.6 amps and not doing anything. Oops. Not moving anymore. Oh, trying. Okay, so I think I put everything into thermal shutdown. Right, okay. 1 Newton fingertip force, then. 1 Newton fingertip force. Okay.